Hello everybody! Today we're going to talk about the Cetus printer, and it is the best Cetus 3D printer that is ever made. Why? It's because all the power electronics is designed by me and not from China, and has very serious advantages over stock printer. It has no printing noise, and I mean it. There's no noise. If you are 10 meters further than this printer, you can't hear the printing. This is just madness. This is crazy, and it's achievable only by using the best of the best stepper drivers, of course from Trinamic. And today we're going to see how this printer performs, how I did it, what's the electronics, what it takes to change it, and yeah, just general things about this printer. And the spoiler alert: printing quality is the same. Okay, so the first thing to do for the printer is to print support for the Z-axis. This is a simple part that includes the brake for the Z motor, that includes a cable guide for this motor. You see how nice, how neat, and yeah, it screws to the rails by three huge bolts, and it screws from the base plate with 2 screws. You can see it here. It's very functional and very sturdy right now. In the stock printer, Wi-Fi antenna was placed in this spot. I mean, it's metal all around, so yeah, you get very good reception. Of course, I put it on the top where it's supposed to be, inside the structure, so my Wi-Fi antenna is in this spot. So it's open to the air, there is no metal except for this cable, and I have very good reception for the Wi-Fi. Also, I included cable guides in this new 3D printer top, so it's centered on the PCB, so it comes out exactly in here. It goes in this channel, and it will go near this tube where it takes the filament, and it's very elegant. And in here, of course, I have the coax for the Wi-Fi antenna. All the axes have home switches, so I have one for the top, I have one in here, and I have one in here. Magnets from the home switches are placed in here, one in here, and second in this new 3D printed part that also acts as guide, but for that I have to drill 2 holes. That's very easy. I made template, it's 2 holes with a 3mm drill and a countersink. That can be made in like 1 minute. That's very easy. And also I have power supply inside this box. Now how can I do it? Well, you will see soon enough. So this is the original electronics, and this is the power supply. As you can see, there is no way I can fit this power supply inside the stock box. That's just impossible to do it. And also, this is designed by child. I have no idea. Of course, that's mine. This is even USB has no ground connection to the main ground. USB is floating. Only shield is connected to the ground, and this is how USB gets this reference voltage. And this is a true statement of differential signaling and how robust it is. USB works only because of differential signaling. And you see the mangled wires from the home switches and the horrible soldering and everything. This is my fine controller, and it's not stock. So this is garbage. I mean, who designed this has no idea how to design electronics, and maybe it was given the task to make it, and well, it kind of works, but it's just horrible. And here we have my own board that I made for this printer. So I have Trinamic drivers, I have STM ARM Cortex F0 processor, and every electronic is designed so the cables are short, neat, USB has ground, and yeah, it also will have a heating pad for the 100 Celsius or even more for the ABS printing. So this printer, when I will finish, will able to print in PLA with no problems. So yeah, I have implemented a lot of features and replicated the stock ones. And the only thing that I'm using is the controller board from the Cetus 3D printer, and everything else is mine. Okay, so let's home this printer. Now look, it's enabled and the fan is not running. I mean, is it hard to implement a simple temperature control? Nah, it's too complicated for Chinese. Okay, so if I'm talking, it's 70 dB or even more. If I stop talking, it's like 40 dB, it's around 40. Okay, so let's enable the printer. Okay. Okay, no noise. It's rising, but there is no noise. Rising, no noise. Rising, no noise. Okay, now it's the home switch. None of the axes hitting the hard stops. None of it. So it's extremely quiet, there is no high frequency pitch for the current stabilization, that rubbish current stabilization that Cetus3D board uses, and it's completely quiet. I can leave this printer, turn on, and I could even tell it is there. It's just so quiet, there is no noise, there is nothing now. Original printer, it has a lot of white noise, you know, shh, like this, like PWM instability for the current regulation. And this one has nothing. It's completely quiet, and of course this fan is lower noise, it's 24 volts, it is thicker because and it can turn the slower, and it produces the same amount of airflow without, I mean 3, 4 times, 10 times less noise. So most of the noise comes from this fan when it's running. So okay, let's see how the stock printer sounds when I turn it on. Okay, so this is the stock printer that I have from my colleague, and let's turn it on. 55 just because of the fan. No motors, nothing. Now let's enable it. Now you can see that you can hear that high frequency noise. That's very annoying. And motors are just, they are not screaming, but they are have very pronounced sound. So mine was 38. This is around 56, 57, 58. So 20 dB in noise reduction, 20 dB. And now it has hard stops, so it's deforming the axis. That's not safe not good for the printer. That's horrible sound when it's homing. So around 57, so 20 dB more just by being on. That's very nice. And there is no supports, there is a very rubbish cable management, but that's normal. Yeah. Motor is heated up the same way, and we have a control. We could make fan to turn it off when it's not used, but we do not use this hardware. I don't know why. We're just stupid, I think. Is it hard to just enable the fan? No, it's too hard. Yeah. And also one more thing for it's warming up for the printer testing. Because it have limit switch based on the back EMF, it's not precise, or at least I cannot make it precise. Of course we have a screw that we have to put it in the less torque between the poles position, so it will be repetitive, but it's not. So each time you turn this printer on, stock printer on, you have to manually reset the table height. With my printer and 1 micron resolution limit switches, because they are Hall sensors, you don't need to calibrate it at all. So that's very nice, the feature. You just put the power on and you can print it, no setup required. Okay, so the stock printer is printing, and it's around 60 decibels. So this is, and it has that stepper motor noise, like CNC noise. Some people find it nice, but when you're printing overnight, well, it's not the best thing. So let's see. Okay, it's around 61, 62 at the maximum sound. And it's the fastest printing speed for this printer. Yeah, not great. Quality is perfect, don't get me wrong, but noise is the issue here. And of course there is no heated plate for this printer. And no limit switches. That's the basic problems of this printer, of the stock printer. Okay, 62 is for the rough highest noise. Okay, so let's see how my printer performs, shall we? Okay, it's my printer's turn, and let's see how it's printing. It's below 50 decibels, so the fan it's much quieter, and the motors are extremely quiet. So it's 10 dB off of original, and there is only very low frequency noise that it's very easy to distance will make disappear. The high frequency, it just permeates everything, and this printer does not have any high frequency noise, only very low motor noise. That's basically it's impossible to take care of, because it's the physical rotation of the motor is what's causing the sound, not the frequency and the amplitude that's going to the PWM signal. Just motor physical rotation. So that's quiet. Yeah, it's so perfect. If I go far, I can hear it, but it's very not pronounced. Yeah, that's just perfect. And of course I have the power supply inside. There is no need for the external power supply. I have limit switches, so no calibration required. Motors does not heat up, well, they heat up just as much as the original ones, and fan is much lower noise, and it will stop spinning and it's finished the job. I mean, now that's a very strange idea, to turn it off the fans when you don't need it. Well, Chinese cannot figure out this part. It's just magic how it's quiet and so on. You have to experience it. So yeah, so this is my boards. Okay, so let's see inside how it looks, because the cable management it's in the completely different level than the stock. Okay, so let's see it. And I have one trick up my sleeve. It's the new smaller, 2 times smaller extruder motor. That's supposed to work just right, and it's 2 times lighter, so it will cause less oscillation in the edges, and something where the extruder change the movement in the other axis, and that's usually cause the oscillation with a frame. And now with 2 times less mass, oscillation should stop to 2 times faster, and I have 2 times higher frequency. That's normal. And here we have a better view of the new guide, and this plate is directly screwed to the carriage, so there is no angle, so it's much more precise, but still it's a better design. So I have direct coupler to the belt, and I have the magnet in here, and it screws directly to this plate. And as you can see, it screws directly to the carriage, so that's much better design. And of course we have to add one more screw for my design to work, because I have same 2 holes, and because it's 2 times shorter, I have 1 extra hole. And this output is for the heated bed. We will see that later. 4 screws later, and we can go inside and just take a look at this board. You will find it very interesting. Yes! Okay, so I disconnected the power and the initialization buttons, and this is the money shot. So original board is rotated, so the RF connection for the antenna is in the right place, so it goes directly to the top, to this printed part, and yeah. So this is the limit switches, and this limit switch is for that's not populated. It's implemented inside this cable because I have 1 spare connection, and of course I have 5 volts, so I have everything I need to power up my sensor that is on the back side of this carriage. So as you can see, I have this will go to the potentiometer for the temperature of the heated surface. So it's like for between 20 and 150 Celsius, so I don't know exact values. This is for the button, and this buzzer. This is ARM STM processor that take care of the initialization of all of these Trinamic drivers. And just take a look how clean that is, how there is no soldering bad jobs, or there's no bridges, nothing. It's very high quality PCB, and yeah, it's just everything is like this connector is centered directly to this rail center. When it screws on, there is no bends in the cable. These connectors are made in the way that they are in the right place where the cable ends. Like this goes like to the, I think this here, this goes to this one, this connector goes I think to this one, and so on. And of course I have the power switch for the heated bed, but that will be implemented later. And I have USB within the ground connection that is connected to the ground. It's so new approach for this printer. Yeah, it's very nice. And of course this goes to the connection to the panel connection in here. And the power supply fits in the same and it's glued with a sticky tape like 2 millimeters, so it cleared this edge. So and it's become heavier, and that's I think good thing for the printer. Yeah, this printer this is what I wanted to buy. It prints very good. It's a good printer in general. Printing quality is just excellent, and now it's quiet, very quiet. And I can print it put it in the other room, and I will not hear it. And this printer, I could hear it from the miles away. This one is impossible to hear if I have my computers running. This is how quiet it is. It's 10 dB lower and 20 dB in the idle. That's just crazy. 20 dB. Yeah. What else? Yeah. Well, not much. So I think I need to square my printer. It's like a few microns off, not microns, like 0.1 millimeter. This is tilted like this. I think it's because these rails are screwed, and this motor is, yeah, this motor is also not making perpendicular to the axis, and the belt is on the side, but that still works. So yeah, if you want a good printer, you have to change a few things, but it's possible. And you can see the cable guides, and for this motor is excellent, and everything is just so nice, so well made right now. Yeah, I really love it, and I can recommend this printer if you do upgrades, or if you don't care about the noise. That's a good printer. Just add a simple comparator for the temperature of the fan control. That's very easy to do. If it's higher than 0.3 volts, turn on the fan. If it's lower, turn off the fan. That's it. How hard it is, I don't know. Yeah. So thank you for watching, and I think if many people want to buy this board, I think I will try to sell it, but it will be quite expensive. I think it's around $100 or something like that, or even more. It's not cheap parts. There is no, well, I tried to make it cheap, but it's not cheap. Yeah, I don't know. We'll see how it goes. Okay, so thank you for watching, and hope you like this video. If you like it, give me a thumbs up, and please subscribe. And I have many more cool projects on this channel coming up. It's one of the best executed projects for me right now, and I have many more with X-rays, robots and BLDC motors and all crazy stuff. So please subscribe and have a good day.